Okay, lesson 2, example 1. Calculate the frequency and wavelength of a photon emitted from a hydrogen atom due to a transition from n equals 3 to n equals 2. So here we have a hydrogen atom. We're seeing the energy levels in that hydrogen atom. And there's an electron inside this hydrogen atom that is transitioning from the n equals 3 energy level down to the n equals 2 energy level. We know that when an electron makes a transition to a lower energy level, the atom will emit a photon. And so we want to know for that photon the frequency and the wavelength. So the first thing we're going to do though is we're going to calculate the change in energy for the electron within the atom. Whenever we're calculating change in energy, we're always going to do the final energy minus the initial energy. So for this atom, the final energy is going to be the energy of the n equals 2 energy level, because that is where the electron ends up. So that's negative 3.40 electron volts. And the initial energy is going to be the energy of the n equals 3 level, because that's where the electron started out. So that's going to be negative 1.51 electron volts. So if we calculate that, let's see what we get. So calculating that, we get negative 1.89 electron volts. So here we're getting a negative value. What this negative value means is that the atom, or the electron, same thing really, lost energy. And that makes sense, because when something is going to a lower energy level, energy is going to be lost. Now, an important thing to know to solve example 1 is that the change in energy of the electron is going to correspond to the energy of the photon that's produced. But energy of the photon cannot be negative. So even though we got a negative value for the change in energy of the electron, when we write down the energy of the photon, we just make it a positive number. So the energy of the photon, we're just going to say that it's 1.89 electron volts. Now remember, the energy of a photon can be calculated by doing h times f. So if we want to find the frequency, we can just take E and we can divide it by h. Now you don't have to write E photon every time. I'm just doing that for clarity, but it's getting a bit long to write. So instead of writing E photon, I'm just going to write E for the rest of this example. So frequency is the photon energy, which is 1.89, divided by Planck's constant. Now remember, there's two different versions of Planck's constant. We're going to use the one that has electron volts in it. So we're going to use 4.14 times 10 to the negative 15 electron volt seconds. And that gives 4.5652 times 10 to the 14. I'm just going to round to 3 significant digits. So 4.57 times 10 to the power of 14 hertz is the frequency. And then we're also wanting to find the wavelength. So the way to find the wavelength is to do C equals frequency times wavelength. So wavelength is the speed of light divided by the frequency. So speed of light is 3 times 10 to the 8. And we're going to divide by the frequency that we just found. So 4.565 ... times 10 to the 14 hertz. And that gives us 6.57 times 10 to the negative 7 meters.